Welcome. Today's video, we are starting section 6.3. We're going to do 6.3 in two chunks. So the first chunk today is separation of variables. We're recognizing and solving differential equations that can be solved by separation of variables and using differential equations to model and solve applied problems. So there's not really much new in this section right now. We're just kind of solidifying some of the techniques we've been talking about and doing a little bit harder problems. So our first example is to find the general solution of the quantity x squared plus 4 dy dx equals xy. And so one thing when we solve differential equations is we always want to take note if y equals 0 is a solution or not. So y equals 0 is a solution to this problem. And because the derivative of that is 0, so I'll get 0 equals x times 0, so 0 equals 0. And when you think about when you get to the end and you have your general solution, you just want to make sure y equals 0 is included in that. If it's not, you can just add that on the end and say, and y equals 0, right? So we'll get there. I'll show you what that means at the end of this particular problem so you can see what that looks like. Okay, so my differential equation is x squared plus 4 dy dx equals xy. Separation of variables, so I'm going to multiply both sides by dx first, and then go ahead and divide both sides by y and x squared plus 4. So I get 1 over y dy equals x over x squared plus 4 dx. Then I'm going to integrate both sides. And then on the left-hand side, we get the natural log of the absolute value of y equals, and then on the right-hand side, if I let u equal x squared, then I get that dx equals du divided by 2x. So then I'm going to have 1/2 the integral of 1 over u plus 4 du. So then I have that the natural log of the absolute value of y equals 1/2 the natural log of the absolute value of u plus 4 plus some constant. And how you know whether to call it just c or c sub 1 is whether you have natural log on the other side or not. So I do, so I'm going to make it c sub 1 because I know when I put it into that exponential form, I can change it into a generic constant at that point. All right, the next step, I'm going to go ahead and substitute back in x squared, and I'm also going to take this 1/2 in as a square root. So the natural log of the absolute value of y equals the natural log of x squared plus 4, which is always positive, so I don't need the absolute value anymore, and then the square root of that plus some constant. And now I'm going to go ahead and put it into exponential form. So the absolute value of y equals e to the natural log of the square root of x squared plus 4 plus c sub 1. Go ahead and split those into two different exponential factors. So the natural log over here times e to the c sub 1. So then I'm going to cancel my natural log here with the e. So then I get the absolute value of y equals the square root of x squared plus 4 times e to the c sub 1. And then if I wanted to get rid of my absolute value bars, I can do that. But the consequence is putting plus or minus on the other side. And then I can also, if I wanted to, I can combine that plus or minus with e to the c sub 1 as just a generic constant. And so I could say y equals c times the square root of x squared plus 4. So that c includes both the plus and minus and the e to the c sub 1. Now if I look here, this first line where I have y equals plus or minus, that is a solution, okay, but it doesn't include y equals 0. Solution that does not include y equals 0. And here I have a more general solution that does include y equals 0. And the reason why is because this would be if c equals 0, I would get y equals 0. And there's no value for c sub 1 that I can plug in that will get that expression to equal 0. So I just want to make sure that, so now I don't need to state y equals 0 is also a solution. All right, let's try the next example. Next example says, given the initial condition y of 0 equals 1, find the particular solution to the equation xy dx plus e to the negative x squared times quantity y squared minus 1 dy equals 0. So first thing we're going to look at is we're going to know if y equals 0 is a solution or not, and it is. So y equals 0 is a solution. But it doesn't meet the initial condition, right? Like, I think there's another I in initial. There we go, initial condition. Great. So we don't really need to worry about that. So we're going to assume y is not equal to 0. Okay, so let's get started. So I have xy dx plus e to the negative x squared times quantity y squared minus 1 dy equals 0. I'm going to go ahead and start to separate my variables by adding or by subtracting that second term on both sides. And then I'm going to divide by y and divide by negative e to the negative x squared. So I have x divided by negative e to the negative x squared dx equals y squared minus 1 over y dy. Then I'm going to go ahead and write that as x e to the x squared. Don't forget my negative. And then on this side, I'm going to go ahead and write that as y minus 1 over y if I divide both of those terms by y. And that should help me integrate a little bit easier. So now I'm going to integrate both sides. Whoa. Oh, dang it. Sorry about this. Where was I? Okay, here we go. I was trying to get more space before it glitched. I apologize for the glitch. Okay, so now we're integrating both sides. Oh, I lost a line, didn't I? I did, dang it. All right. Okay. What did I lose? Okay, so I had negative x e to the negative x squared dx equals y minus 1 over y dy. And then I'm going to integrate both sides. Oops, I don't need a negative on that exponent. All right, so now we're going to integrate. So I get the integral of x e to the x squared dx. And then on this side, integral of y minus 1 over y dy. So when I integrate, if I let u equal x squared, then I get dx equals du over 2x. So the x's will cancel, which is fantastic. So I get negative 1/2, and then the integral of e to the u du. Then over here, I have the integral of y, which is y squared divided by 2, minus the integral of 1 over y, which is natural log of the absolute value of y, plus c. So now I have negative 1/2 e to the u, which u is x squared, so I'm just going to go ahead and substitute that back in right away. And then y squared over 2 minus natural log of the absolute value of y plus c. Fantastic. I have y in a natural log and also in a quadratic expression, so it's going to be pretty impossible to solve for just y. So in this case, a general solution, what you would do is you would put all of your x and y terms on one side and your constant on the other. So my general solution might look something like, oh, and I'm going to multiply by 2 on everything just to get rid of those denominators. And that 2c would just be another constant, so that's perfectly acceptable. So I would have negative e to the x squared minus y squared plus 2 times the natural log of the absolute value of y is going to equal some constant, which is 2 times the constant I have in the previous line, but that's okay. Now we have our initial condition where if we plug in 0 for x, we get 1 for y. So now I have negative e to the 0 minus 1 plus 2 times the natural log of the absolute value of 1 equals some constant c. So I get negative 1 minus 1 plus 0 equals c. So c equals negative 2. And so then my final answer here would be negative e x squared plus, oops, not plus, minus y squared plus 2 natural log of the absolute value of y equals negative 2. Or another way to write that, if you don't like all the negatives, I would prefer if it started out as a positive and my constant was a positive, so I'm just going to flip the sign on everything. Either of those answers would be acceptable. All right, next example. Example 3 says, find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point x, y. All right, so for this one, we are going to start with our differential equations. So we know that the slope, or the change in y, with respect to x is y over x squared. So then I'm going to go ahead and separate my variables, and I get 1 over x squared dx equals 1 over y dy. Integrate both sides, and I'm going to get negative 1 over x on this side plus some constant. Doesn't matter which side you put your constant on, but I'm putting it on that side because my other side has my natural log on it. So natural log of the absolute value of y. So then I'm going to raise both of them as powers, or put it in exponential form essentially. So I get the absolute value of y equals e to the negative 1 over x plus a constant. Once again, we get plus or minus, and we can also do the e to the c sub 1 as a new constant. So I'm going to write this as y equals some new constant. So that includes the plus or minus from the absolute value and e to the c sub 1. And then e to the negative 1 over x. And so then now if I look at this at my point 1, 3, so I'm going up here now. So at my point 1, 3, I get 3 equals c e to the negative 1 over 1. So then I get c equals 3e. So now my equation is y equals 3e times e to the negative 1 over x. Remember, there's an exponent of 1 on that first e, so I'm going to combine like bases. 3e to the negative 1 over x plus 1. That would be an acceptable answer if you like to have common denominator within that exponent. You would have 3e, and then your exponent would be x minus 1 quantity over x. And that would be our final answer. Either of these would be appropriate. Great. Last example of the day. Oh, yeah, and here's a graph of that. So we see that we kind of have a max here at 3e. And our function is approaching that. So kind of a cool graph there to visualize, which we're going to see a little bit of that in the next example. Go away, bottom. All right, the rate of change of number of coyotes in a population is directly proportional to 650 minus n of t, where t is the time in years. And when t equals 0, the population is 300. When t equals 2, the population has increased to 500. Find the population when t equals 3. Okay, so if we know it's directly proportional to 650 minus n of t, that means that dn dt is going to equal some constant times 650 minus n. So I'm going to go ahead and separate my variables here. So I get dn divided by 650 minus n equals k dt. Go ahead and integrate both sides. So I get the natural log of 650 minus n, and since the derivative of the inside is negative, I need a negative on the outside, so that's chain rule or substitution. Either way, you'd figure that out. And then on this side, I get k times t plus some constant. And then I'm going to go ahead and put that negative on the other side. So now I have that the natural log of the absolute value of 650 minus n equals negative k of t minus my constant. And go ahead and put that into exponential form. So I get e to the negative kt minus some constant. And I'm going to make that e to the negative c sub 1 some new constant. Also include the plus or minus from the absolute value in that. So now I can write that as some new constant c times e to the negative kt. I'm going to subtract 650 and multiply by a negative 1 on both sides. So now I get n equals 650 minus c e to the negative kt. Plug in my point. So my point now is at 0, time was 0. My population is 300. So knowing that, I get 300 equals 650 minus CE to the 0. And that gives me that C equals 350. So now if I'm at the point, the next point they said was at t equals 2, my population was 500. So now my equation is n equals 650 minus 350 e to the negative kt. We're going to plug in 500 for n, and we're going to plug in 2 for t. So negative 2k is my exponent. So then I get, subtract 650, so I get negative 150 equals negative 350 e to the negative 2k. Solving for k, let's see, we get 3/7, the negatives will cancel, equals e to the negative 2k. Take the natural log and divide by that negative 2. And that's what k will equal. So I'm going to go ahead and store this in my calculator, so that STO button. And I'm going to store it as k because, you know, I like to. And you should get that k is approximately 0.4236. So my final equation is n equals 650 minus 350 e to the kt, and k is negative, negative 0.4236 t. So that's my final equation. And you can see here it like kind of looks like it's leveling off. Like there's a carrying capacity for how large your populations can be. And that's based on the size of the environment, the size of the food source, different things like that. All right, so then to answer the question, we need to figure out when t equals 3. I have n equals 650 minus 350 e to the negative 0.4236 and then times 3. And when I would enter that into my calculator, I wouldn't use the approximate. I would use my STO button. I would use the actual value of k. And so to use that, you don't need to hit STO. You can just hit the alpha k, and it will give that to you. And we would get approximately 552 coyotes.